What if the missile Iran spent decades claiming it would never build has already crossed the threshold everyone was watching for? Not with a dramatic announcement, not with a parade, not with a world-changing speech, but with a single launch that quietly changed the map. Because somewhere inside defense circles, a number began moving, 4,000 kilometers. And that number matters because it represents more than distance. It represents a question: did Iran's missile program just enter a new strategic category? For years, the world accepted a very specific story about Iran's ballistic missiles. Tehran repeatedly insisted its missiles were designed for regional defense. The official limit was simple: 2,000 kilometers. Enough to threaten Israel. Enough to reach American bases across the Persian Gulf. But not enough, Iran argued, to threaten Europe. That boundary became part of the strategic conversation. It was not just a technical specification, it was a political message. Iran was saying, we have capability, but we have limits. But missiles are not defined by political statements. They are defined by physics, and physics has a way of exposing hidden ambitions. A longer-range missile requires more than simply adding fuel. The airframe must survive greater stress. The engine must produce more sustained power. The guidance system must remain accurate across a much larger distance. Every additional kilometer creates new engineering problems. So when Iran repeatedly stopped at the 2,000-kilometer line, many analysts believed that limitation was at least partly real, until the launch that changed the conversation. On the 20th of March, Iranian forces launched ballistic missiles toward Diego Garcia, small island in the Indian Ocean, a joint American and British military facility, thousands of kilometers from Iran. On a satellite map, Diego Garcia looks almost insignificant, a tiny piece of land surrounded by an enormous ocean. But strategically, it is a symbol of Western military reach, and that was exactly why the launch mattered. The missiles did not successfully destroy the base. One reportedly failed during flight. Another was reportedly intercepted. On paper, it looked like a failed attack. But here is the problem. A failed strike can still reveal a successful capability, because countries do not attempt 4,000-kilometer missile launches by accident. The missile does not have to hit its target to send a message. The attempt itself becomes information. It tells intelligence agencies, some unknown inside the system believed this distance was achievable, and that changes the calculation. The part most people miss is that missile warfare is not only about explosions. It is also about forcing an opponent to think differently. A weapon that changes an enemy's planning can be strategically valuable before it is ever used successfully. And that is exactly where Iran's missile program becomes more complicated, because this story did not begin with Diego Garcia. It began decades earlier, during the Iraq War in the 1980s. Iran faced a major military disadvantage. Its air force was weakened. Foreign weapons access was restricted. Traditional power projection was difficult. Missiles became the alternative. They offered something aircraft could not provide: the ability to strike without controlling the sky. Over time, a survival tool became the foundation of a larger strategy. Missiles became Iran's insurance policy, a way for a country under sanctions and pressure to create uncertainty among stronger opponents. The lesson here is important. A missile program is rarely only about the missile. It is about the strategic problem. The missile solves for Iran. The problem was simple. How does a regional power challenge opponents with stronger air forces, larger economies, and global alliances? The answer was not matching them weapon for weapon. The answer was creating costs. But now the question has changed, because range changes everything. A 2,000-kilometer missile creates a regional problem. A 4,000-kilometer missile creates a much wider strategic problem. On a map, that circle expands dramatically. It reaches deeper across the Middle East. It touches North Africa. It places major European cities inside the theoretical range envelope: Berlin, Rome, Paris. But distance alone does not equal power. And this is where the story becomes more complicated. A missile being physically capable of reaching somewhere does not mean it can reliably strike that location. Accuracy matters, reliability matters, numbers matter. A single missile is a demonstration, a large inventory, but here is the contradiction. Military planners do not wait until every uncertainty disappears. They prepare for possibilities before they become realities. Because by the time a threat becomes obvious, it may already be too late to respond. That is why a second number began attracting attention. 5,000 kilometers. Unlike the 4,000 kilometer capability, this number is not confirmed as an operational missile. It comes from analysis of Iran's space, launch technology, especially systems designed to place satellites into orbit. And this creates an uncomfortable overlap, because rockets that launch satellites and rockets that deliver warheads share many of the same technological foundations. Propulsion, guidance, multi-stage flight, payload delivery. The mission is different, the physics is not. The question is not whether a satellite rocket automatically becomes a military missile. It does not. The question is whether the technology behind one can eventually accelerate development of the other. And that possibility is what concerns many analysts. Because the hardest part of missile development is often not building a longer tube. It is mastering the engineering knowledge behind reaching extreme speeds and distances. Iran has spent decades building that knowledge, but the deeper story is not just range. It is adaptation. Modern missile warfare is no longer only a contest between launchers and interceptors. It is a race between offense and defense. Every improvement creates a new vulnerability. A missile becomes harder to stop. So defenses must become more advanced, more radar, more interceptors, more spending, more political pressure. And that creates the first glimpse of the hidden battlefield. Because everyone is looking at the missile. But the real question is what the missile forces everyone else to do. European governments must reconsider air defense. NATO planners must examine new threat zones. Regional powers must decide how much money they can spend preparing for future possibilities. The missile does not need to destroy a city to create strategic consequences. It only needs to change decisions. And that may be the most important shift of all. Because the next phase of this story is not about whether Iran has a missile that can travel farther. The next phase is about what happens when a weapon changes the behavior of everyone watching it. And that is where the real battlefield begins. Everyone thinks this battle is about missiles reaching farther. But the real battle is about something much harder to measure. Control. Because the most powerful weapon a missile creates is not always the damage it causes. Sometimes it is the uncertainty it creates before it is ever launched. That is the invisible battlefield. And this is where Iran's missile program becomes more than a military technology story. It becomes a geopolitical strategy. A missile sitting underground does not need to fly to have an effect. It changes military planning. It changes defense budgets. It changes political conversations. The weapon is not only the missile. The weapon is the possibility. This is why range matters so much. A missile with extended range forces opponents to defend more territory, and defending more territory is expensive. Every radar system, every interceptor battery, every aircraft placed on alert, every intelligence asset tracking missile activity, all of them require resources, and resources are limited. The bigger picture is that modern warfare is often a battle of systems, not just weapons. A missile program challenges not only another missile system, it challenges the entire network built to prevent it. But here's the problem. Defense is usually more expensive than offense. A country can spend years developing a missile. An opponent may need decades of investment to create a shield against it. This creates a strategic imbalance. And that imbalance is exactly what makes missiles attractive to countries that cannot compete through traditional military power. Iran understands this equation. A fighter aircraft requires pilots, maintenance, airfields, large supply chains. A navy requires ships, bases, global logistics. But missiles offer something different. They compress power into a smaller, harder, To eliminate package, that does not make them unstoppable. It makes them strategically efficient, and that distinction matters. Because the question is not whether Iran has created a weapon that guarantees victory. It has not. The question is whether Iran has created a weapon that forces stronger opponents to spend more time, money, and attention responding. And strategically, that is a very different kind of power look. Again, at the Diego Garcia launch, the physical result was limited. The missiles did not destroy the target. But the strategic effect was much larger. A single launch forced analysts to reconsider assumptions that had shaped years of planning. That is the hidden value of missile development. It creates uncertainty, and uncertainty creates pressure. The same pattern can be seen in other parts of Iran's missile arsenal. Systems like the Haram-Shar family, the Khaibar-Shekan, and the Fatah series represent different approaches to the same strategic goal. Increase the cost of intervention. Some focus on range. Some focus on speed, some focus on maneuverability, but the goal remains similar. Make the opponent's advantage less certain. The Fatah family is especially important because it highlights the next stage of missile competition. Traditional ballistic missiles follow predictable paths. A defender calculates the trajectory. A radar system tracks the object. An interceptor is launched toward the expected point of impact. But a maneuvering warhead changes the equation. The missile is no longer following a simple path. It can adjust, it can complicate prediction, it can create hesitation. The lesson here is that modern warfare increasingly depends on information. Who sees first? Who decides faster? Who adapts quicker? The missile is only one part of the system. The battle begins before launch, deep underground, inside command centers, inside intelligence networks, inside political decision rooms. And that leads to the next question: why would Iran invest so heavily in a capability that still faces technical limitations? Because the purpose may be deterrence. For decades, smaller powers have used asymmetric strategies against stronger opponents. The idea is simple. If you cannot guarantee victory, create enough uncertainty that the opponent questions the cost of action. A missile does not have to defeat an enemy army. It only has to influence the enemy's decisions. That is why a missile aimed thousands of kilometers away matters, even if it never reaches its target. The possibility changes behavior, and behavior is the foundation of strategy. But the missile story is also connected to something much larger. Energy. The Middle East remains one of the most important regions in the global energy system. The Persian Gulf, the Strait of Hormuz, oil infrastructure, shipping routes, all of these are connected. A country that can threaten regional military infrastructure can influence economic calculations far beyond the battlefield. A missile launch can affect markets, insurance costs, military deployments, diplomatic negotiations. The explosion may happen in one place. The consequences spread worldwide. That is why modern conflicts cannot be understood only by looking at weapons. The battlefield extends into economies, supply chains, energy markets, political alliances. And this is where Iran's missile strategy becomes especially significant. Because missile capability gives Tehran a way to remain relevant, even under economic pressure. Sanctions can damage an economy. Military strikes can destroy facilities. But knowledge is harder to eliminate. Engineers remain. Factories can be rebuilt. Design experience survives. The part most people miss is that military capability is not only hardware, it is industrial memory. A destroyed building is visible. A surviving engineering team is invisible. And invisible capabilities are often the hardest ones to measure. This is also why comparisons with other missile programs matter. North Korea provides one example of how a country can gradually expand missile capability over time. Early tests appeared unreliable. Many observers underestimated them. Then the technology improved step by step, range increased. Reliability improved, the strategic calculation changed. The lesson is not that every country follows the same path. The lesson is that early warning signs are often ignored because individual steps appear too small. Strategic shifts rarely happen overnight. They accumulate: a test launch, a new engine, a longer range, a better guidance system, a new production facility. Then suddenly the world realizes the balance has moved. That is the concern surrounding Iran. But what today's technology allows tomorrow. Because the difference between a regional missile power and a global strategic concern is not always one revolutionary breakthrough. Sometimes it is a series of smaller improvements that nobody takes seriously enough until they connect together. So where does this leave the world now? The confirmed picture is clear. Iran has demonstrated missile capability beyond the range it publicly emphasized for years. The 4,000-kilometer threshold changed strategic assumptions. The 5,000-kilometer discussion represents a possible future direction, not a confirmed operational reality. The uncertainty is exactly what makes the issue difficult. And uncertainty is where strategy lives. The question is no longer whether missiles are just weapons. The real question is whether future conflicts will be decided by the side with the most powerful systems, or by the side that creates the most uncertainty for everyone else. Because the next generation of warfare may not be defined by the missile that hits its target. It may be defined by the missile that forces an entire world to change its decisions before it ever launches. What do you think? Will future wars be won by superior weapons, or by the ability to control the choices of your opponent?